stuff. Okay. So I have on here that we're starting for test 4. It starts with within subject designs is the first concept. Okay. Should put on here. Test 4. Okay. So, right. So the within subject, the basic concept is that you are kind of like plotting out each person. You're comparing each person to themselves, is basically. So that, so that's helpful because like you have less confound. Like if you're doing a study, if you're comparing everyone to themselves, like stuff like SES and gender and all those kinds of things are not going to influence your results as much. So that's like positives of doing a within group design. And then also you can have like a smaller sample size if you do a within group design.
Why is that? The more subjects you have, or that in the book, and the less. The more scores you have per subject, the less subjects you need.
Right.
Why?
Because, like, if you think about it, like, the greater number of stuff you have increases, like, the power. So if you have more scores, then you would need less subject. Because, like, if you have, if each subject only has one score, then you need more subjects to compare all the different scores. But if each subject has multiple scores, then you don't need to have as many people for the same comparison. So having it increases, the more scores you have, increases the power. So it's kind of like that's all about. So it's a good method to use, and not a lot of people always think about it sometimes, but if you can build it into your design, like when you do your dissertation, like Dr. Brown says, like it's a good method, because then you reduce your confounds, and then you also don't have to recruit as many subjects. It's kind of cool. So then we have to look at, within subject design, we have to look at the sphericity assumption. And so that's like what he said with like the Finding Nemo, where everything kind of, like goes along a similar pattern, like this kind of thing. So there's not like one person that's over there or something, like that would, this person's not, and like another way he described it that was kind of good was like, if you watch the Tour de France or something, and all the bikers are all going, in the same pattern, but if like one person like falls and like falls down the side of the mountain, that would be a violation. So basically, you want to make sure that that people are changing kind of like in a similar fashion. That there's not a there's not this one person that's going like this. That pretty much the pattern of people over time is like this kind of same general thing.
And the other two violations that we're using are independence of observation and then normality.
Right.
Okay, we discussed yesterday that it's not that, but it's for within group it's homogeneity and I know. Well, she looked it up in the book. Oh, I'll show you what page.
Show me what page.
It was. I know it's weird, but actually.
Dr. Jason.
Well,
They can't be.
It says Jacqueline's right when. Sorry. Okay, sorry. Observation assumption is not important for within group design.
Right, because that you're comparing people to themselves.
Independence of observation?
Yeah.
Yeah.
No.
Sorry.
I thought independence of observation was important, but homogeneity wasn't, because you're not testing the variances of all of them together. You're looking at like one person.
So it's C page, or C page
So what is
372.
372.
Cassandra did. 372.
Not correlations between people. So like Let's see.
Like
a good example.
I'm trying to think. Casandra used a good one yesterday. Like, we don't care if their reactions to different treatments are dependent on the last treatment. Does that make
Right.
sense? Okay.
Well,
No.
Well,
I'm not saying
no,
it right.
because that's kind of carryover effects,
Yeah, I know.
which are important. It's
Showing a really good example. 372.
It's like independence of observation is like when you have like all these different subjects, and like whatever their scores on different stuff, they're like. Think of a good example. Do we have? Let's look it up in the book and see if they have a good example. So it's like independent observation sound. So speaking. Yeah, they don't even have it in here.
I remember these.
They don't have it in your appendix. But yeah, but it's basically like it doesn't matter because you're comparing people to themselves. It only matters like when you're comparing people, like when you're doing a between groups design and you have multiple individuals.
Like medicine, or you're using like some kind of drug. Like obviously, it's going to have some sort of effect on the next observation. So of that same person, right?
See, then we said that was going to be carried.
Well, I'm gonna get a good like independence of. Why don't they have this as like a?
Page 372.
That's on page 72.
Yeah.
Let me see if I have it in my notes somewhere. Because I want to make sure.
Not independent of each other, and the statistical model needs to accommodate these dependencies. On top of page 373.
Right. Are not independent of each
Do you
other.
wanna-
But that's not independence of observation.
Oh, okay. I was looking here.
Assumptions. Okay, independent of right. Right.
High score. What treatment likely to have a high score?
Cluster of random sampling assumptions. In particular, each subject's data must be independent of the data from every other subject. So that's the independence of observation assumption is
I did write that down. Like these are the three
for within group.
within group.
Oh, okay.
But I don't know if that's.
See, I don't have that written down in my notes.
I'm almost 100% certain what he said was there was no homogeneity of variance, and that was the difference. That's what I had in my notes from what he said in the lecture.
Okay.
So I think that's still how I'm going to answer it on the test. If he says that was wrong, I'm going to be like, well, he said it wrong in class. So. I think so, because that's what I remember him saying.
Cody, I mean, I asked Cody specifically about this, and he said for sure scarcity is in and independence is out. I'm not saying, I'm just saying it's another perspective, and then Casandra also said. I'm just saying, I would hate for you to get it wrong.
Right, because the assumption of independence applies to the subjects, not to the individual scores. that's the, but, you know, so that's what I'm trying to verify. But let me see.
She's good. She's saying hello for sleeping. That's what you're saying. Okay.
So, but then,
what is homogeneity like as in regards to within group? Maybe that'll help. Why would we not want that?
Well,
I mean, I think we would want it, but maybe to help this discussion, like we
Okay.
could focus on.
well, homogeneity is like, so in between groups, it's when like you have, you know, all these individual points,
Yeah.
and they're kind of, you know, in a uniform pattern. So that it's kind of, so the sphericity is well, I don't want to say that. Let's say it's sort of akin to sphericity, but this is one person. Instead of like a score, it's like one person, and each person is going in the same pattern, rather than between group scores going into the same pattern. So that's kind of different. I don't know. Does that make sense?
Yeah, we want to look at the same pattern, but in between group, we want to look at the patterns of different people, and within group, we want to look at the pattern of one person, different scores.
So we do want homogeneity. We want there to be a pattern.
Yeah.
Okay, so in independent
Definitely.
Okay, let's move on.
I think so, but I don't want to. Now I'm confused too, because I'm like, wait a minute. Because if you're saying he said that, see that's what I'm saying. Like in the homogeneity is about the between scores, and the sphericity is the individual people, kind of like going in the same flow. So does that make sense?
It does.
Okay, good. All right, so that part makes sense, and we're still confused. Maybe Casandra can save the day. I can't find that in my notes. It's driving me crazy. So we're talking about...
We're in an argument. Or now?
Yeah.
We're in a disagreement.
I guess he said in class that independence of observation is important in the within group.
Is important or is it not important?
Well, I would say is not.
I would agree, because that's what
Right. Okay. But then there's some confusion, because I guess he might have said in class that it is or something. I don't know. But and then this is the paragraph that, like, it's the That's the difference. Because even though people's scores might be correlated over time because it's the same person, but that's carryover effects and practice effects, and due to just like the order in which you present different things to the different people. But it's not due to like other people's scores influencing those scores. Like that's the independence of observation assumption. Yeah. Like other subjects influencing that other subject. So, but now I don't
Complicated.
know. Yeah, it's complicated.
We should ask them in class tomorrow.
Yeah.
There's just one girl here taking it today.
Oh, yeah. Sherilyn's taking it today.
Oh, you are?
Yeah.
Well, ask him before you take the test.
Right.
Oh,
Yeah, be like, oh, I, right.
He's giving it to you.
Oh my gosh.
Yeah, do it.
Be like, I was
The
confused.
independence of observation is important within subjects design, because we had confusion with the
Right.
TAs in the review session.
Wow.
Okay,
Yeah.
so let's move on then.
Okay.
That sounds good?
I'll email you guys and let you know what he said.
Okay.
Yeah.
Because it seems like it does and it
right,
doesn't.
because we're both saying,
Okay, but-
like, right, because I can see in terms of, like, their scores, but that's not, I don't think that's really what the assumption says, but I could be wrong.
Because they are correlated within the subject across the treatments, but you don't want them to be, you want them to be independent between subjects, but not.
Right. So, since there is no between subject, it seems like it wouldn't matter, but.
We can just go on to the next one.
Yeah.
You guys and we'll settle it.
Yeah. Okay. Sounds good.
What time is it in test? Like 12:30.
Okay.
Oh, okay. Yeah, time then. Plenty of time. Okay, so what's the, I lost my list now. Oh, okay. Oh, practice and carryover effects. So we kind of just talked about that. Does anybody have any questions?
Yeah, can you
Oh, say what that is. Okay, so that's like if you're, so carryover effects is like when you test somebody on one thing, you know, like give them a survey or something to fill out, and their results, you know, them having taken the same survey like 2 times in a row, that affects the second score. Just them having repeated the same thing. So, so yeah, the carryover effect.
Like on a pre and post test, they're going to know if
Yeah.
they took it before, they're going
Right.
to know after the treatment, they're going to expect
Yeah.
some of the questions.
They've already been
Right.
exposed to the test.
Yeah.
That's going to have an effect on their second score. But,
Mhm.
which is why some tests have like, you have to wait this long until you have people take the test again.
Right. So
part
they're
of when they
likely to
create it.
remember the questions and stuff. So yeah.
The carryover would
Practice.
Is that practice?
Well, practice effects is more like, isn't that like if you're providing a treatment and like, you know, you're seeing the same person like multiple times and stuff like that. So it's like it could be the relationship with that person that's really like influencing the results, and not like right, and not like the fact that you went to this many like treatment sessions. So it's like not the treatment necessarily, but it's like maybe your relationship that you developed with this therapist.
Well, like if you come in nervous the first time and you're not nervous the second time because you've already taken the checkpoint. That's
Right.
like your score.
Something like that too. Yeah. So
So
yeah, so they're related. They're similar.
Okay, so that has, the practice has more to do with not the results, but more of the
like environmental
environment interaction.
factors, like relationship with that therapist, or you know, being nervous the first time you took it, and then you're not nervous the second time you came in because you know what to expect, kind of. So it's sort of like has to do with expectations. Both of them do. Yeah. Let's see. Any questions about that one?
Wait, what did we say? Did we say practice is the test taking?
No.
No.
I think we have it backwards. So practice effects is what we said the first time, is when you take a test and take it again, you practice taking that test. So carryover is actually when you have different treatments, and one
Oh.
affects the other. So if you have like a Latin squares design, you know what that is from the book. So it's when you want to compare two different treatments on subjects, perhaps. So you have one treatment, and then you have them exposed to another treatment. And so the carryover would be the effects of that first treatment on the second. So maybe if you had like a CBT group, and then biofeedback for me.
That's right.
And so
Or
whatever the effects for the CBT treatment would be carrying over to the biofeedback.
Mm-hmm.
So that's why you have Latin squares, which is where you would have some subjects exposed to CBT and then biofeedback, and others biofeedback and then CBT. That kind of compensates for that. So yeah, carryover is like treatment effects carrying over to the next. And practice is when you do a pre and a post test, and you practice taking that test.
You've had practice.
Mhm.
Okay.
And it affects.
That's a good way to remember it.
performance
So
on
you've
the
had
test.
practice versus treatment carries. And then also the carryover effect can also apply to drugs. Like if you,
It's treatment.
so that's another form of treatment. So if you take one drug and then you take another drug later on, the effect of the first drug could be influencing the second drug results or whatever.
That's like form shadow.
Yeah,
Yes.
but you don't have to know that about it. I just brought it up as an example.
Yeah. I think we did that last. No, we didn't do that last time. We did the nested design. Okay. And then we already kind of talked about sphericity. I talked about the.
So what's the example he gave in class for sphericity, or the analogy?
You want all of the people to like score in the same direction.
Yeah, you want all the scores changing about the same rate.
Yeah, in the same way.
And then the way to correct for that is the different score, but then you did not use the different score because it's not like a good thing to use, right? Because if you get like the difference between like 10 and 20 is different than a difference between like 70 and 80, even though the difference is 10. Like, isn't that the way that like some people correct for sphericity, but he did not to do that?
I wasn't there for the lecture, but
Oh.
corrections for sphericity are in the output that you would generate with SPSS. There's the greenhouse geyser, the hump belt, and I always forget the third one. Lower bound.
Oh, okay. Yeah.
But hump belt seems to be just about right in regards to over conservative or under conservative, or less and more stringent. So that's why we use that, and that corrects for a violation sphericity, because when you violate sphericity, your F value is overinflated. So
Right, because the influence of this one person, like going off the path, like that big difference is going to influence your F.
So it makes a bigger F.
bigger F. So what would that mean if we had a incorrect bigger F? Yeah.
Yes. Increases type 1 error.
So it corrects for that by decreasing the degrees of freedom. So with that correction, you have a new F. So that's how you compensate for that violation. You can use those three corrections, or you can move to a MANOVA design.
And then it was the greenhouse that wasn't conservative, and that was
The Mockleys is the actual test of the assumption.
So that's what you do in a greenhouse or in a
So you first look at the Mockleys. Okay, is Mockleys significant or not? And if it's significant, then it's bad. It's violated.
So same as homogeneity. If it's significant, then it's violated.
You don't want significant.
So you don't want significant.
Okay, and then also he mentioned last night, so a strong score like that we might get on the Hunt belt is the closest to 1 is possible.
Yes.
Yeah.
Okay.
Because the farther, so the values you'll get for hump belts and greenhouse guys are from 0 to 1. So the lower it is, the more it's being corrected. So if it's like 0.99, then it's not being corrected that much. So it's a good thing.
Can you say that one more time?
So between 1 and 0, it'll give you the value, and the farther away, the lower it is, the more sphericity is being corrected for, or the violation the larger violation, so the more correction is needed.
So the closer to C0, that's more violation.
Yeah, there's more violations. So the closer to 1, the better off you are in regards to
So if
that
you get a
violation.
1 subject, you don't need a correction?
Wait, I'm confused.
Yeah, he didn't say that actually.
He didn't say that?
They should, yeah, he did. He said they should all be 1.
Yeah, they should all be 1.
That means that you didn't violate diversity, right?
Yes.
So
But you also want to look at the mock leaves. The mock leaves will be the first thing you look at, and then you can use the other ones to see, okay, how violated was it? But you're pretty much going to use the hump belt because that's what he recommends to use when you do need to correct.
So is it not that you look at the Monchi first, and if that is not significant, then you look and you do the corrections? But if it is, I thought if it was significant, that's when you do corrections.
Yeah. Did I say that?
Yeah.
No, but then if you're correcting for it, why are you finding if there's a violation or not? That's what I'm confused. Like,
Well, it's pretty much looking at it 2 ways.
okay. So it's not changing it so you can continue on with your.
The mock leaves isn't. The mock leaves is just, is it violated, yes or no?
But the correction is like it's continuing it. You're changing your
Yeah,
apps
the
so you
correction is
can
the second step.
Go
like,
on
okay,
with your study.
This is the one that I want to use from now on. I want to look at the hump belt F. Because it'll give you an F value for the greenhouse geyser, for the hump belt.
So when you were saying that if it's lower, it's violated.
Well, I'm talking about the actual numbers, the actual hump belt value, the actual greenhouse geyser value. I should show you
Yeah,
output.
if we had the output, that would be really
I think I might have.
helpful.
Because there's actually 2 tables that
Right.
get printed out.
Yeah.
Okay.
So
So with the mock leaf test, they'll give you the mock leaf value here, and then they'll give you the corrections, right?
Right.
The epsilons for greenhouse geyser, hump belt, and lower bound. And then in another table, they'll give you the greenhouse geyser, hump belt, lower bound, and all the F's and significance and effect sizes, just like a regular NOVA table, but with the corrected values.
Okay, and when you say you need more correction, what do you do then? So let's say your number is really low, and you need more correction. So you have to change your study? Is that basically saying that there's too much xericity?
Yeah, I think if like Hunfeld is
So this is not
like
exactly.
not
Okay, not
close
so you
to
don't-
1
you
at
don't
all,
have
I
right?
think
You
Okay.
So,
All
yeah, so like you would, so right, so the correction, like if violated, then Hunfeld comes out, like blah, 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 and I don't know, I've never seen one that wasn't like
Pretty close to 1.
right. So like if it's not, it's probably like a huge flaw in your design. I think, but we can double check. So if it's like not, she's asking if it's not close to 1, like the Hunfeld, like when it comes on output, that's just like a design flaw. Like there's nothing, like your interpretation of your result is like,
Well, it's really easy to violate diversity.
right,
Really easy. That's
Right.
why that's kind of a drawback of this design with this subject. But
right. But the epsilon, like, so when you go and look at your epsilon values, like if this is like really, really low or something, like that's kind of just like a design problem.
Oh.
Yeah. Like, you know, like in looking at your, you know, you can still report all your F stuff, but like if your Hunfeld is like 0.2 or something, you know, if it's really bad or something, you know, there's not much validity to, or, you know, like you can't really put a lot of like, I really believe in these results, they're really awesome.
Yeah, it tells you how far it was violated, and you might want to move to like a different design,
Right.
like a Manova design.
Right,
If it's
you might want to
a
do
really severe violation.
something else. Yeah, so.
Because the Manova, you don't
unfortunately.
need that assumption.
Right, yeah, you could do Manova.
Or if
Yeah.
you're looking at it with just a contrast, so like if you're, because remember with sphericity, you can't violate it if there's if there's only 2 levels, you can't violate it.
Okay, that's what's confusing me too.
Right.
The decision
That's
tree
good.
said. So,
Yeah.
on the interaction,
Mm-hmm.
like when it said, is there a significant
written down.
yes, and it said, analyze blah, 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 but if it's significant and bigger than 2 levels, do simple comparison. Because are you talking about the same like,
Oh.
or is it different?
I think we're talking about something else.
Okay, then we'll go to that later.
You were talking about 3 ways?
Mm.
I don't know how that's different. I think
Yeah, but you can
I have that written down about sphericity. I saw that. I wanted to mention.
Yeah, well, so just remember how sphericity works. They're changing together. But if there's only 2 levels, there's really only like this much change. It's a lot. You can't really violate that as much. You can't.
Right.
You can't violate it because there's only 2 levels, and so if you're looking at a contrast, you're only comparing 2 groups, 2 levels. So that assumption is not relevant to just a comparison of 2 levels. So if you break your analysis down to that sort of analysis, just 2, one versus 1, you don't need the sphericity assumption.
When you're saying one person versus the other person.
One condition versus one condition for the within subject design.
Okay.
So
Like
remember,
one independent
all the
variable?
subjects are being exposed to different conditions. But if you're only comparing 2 conditions, and you don't need the sphericity assumption to be, it doesn't matter if it's valid or not because it's not relevant to that comparison. Does that make sense?
Are we talking about the ANOVA?
We're talking about like a simple comparison.
So once you break down a 3-way interaction into a 2-way interaction, it's no longer relevant to sphericity, is what you're saying.
Right.
Yeah.
For sphericity, yeah. So if you only have 2 levels at the IV, then the sphericity assumption, you don't have to worry about it anymore.
I'm talking about if it's violated.
Right.
That's another way to work around that violation. Change the way you're analyzing your data. Okay, I'm only going to look at these 2 groups.
Right. Simple comparison.
I don't need the sphericity assumption, even though it's widely violated, because it's not relevant for just comparing 2 groups. That's what I'm getting at.
Right. And then other things you can do is you can do a MANOVA or hierarchical linear model.
Hierarchical linear model.
So those are 2 other things you can do, and that's what he was talking about with the difference scores. Like for those, you can calculate a difference score to represent change over time.
Oh, okay.
Yeah, and that's what you can do if your design is like, and you have to like change it to a MANOVA or HLM. But probably what he was saying is that's kind of like what he was saying with the, like, you know, the difference between a 10 and a 20 is 10, and a 70-80 is 10. And so basically you're saying, okay, well these people had a difference of 10 in their score, but that's not really the same difference, you know. So he's saying that that's like a limitation to doing it that way, is that you're not really going to get, it might not be quite accurate, like, you know, because somebody that got a 10 and then a 20, you know, like that whole thing, it's different than somebody that had a higher score a little bit.
Is that the same thing as the delta?
Yeah.
Yeah, delta means change. Yeah. So those are ways you can correct for it, and then you don't have to correct if your IV only has 2 levels. So you can make your IV only have 2 levels, or you can calculate the different scores and do the MANOVA or the HLM.
HLM wasn't on our sheet though, was it?
Right, no. You don't have to know, you just have to know that, like, you know, that's like a different thing you could use instead of the within subjects if sphericity is violated. Yeah. So yeah, you don't have to know.
So correction.
Right.
If it's violated, this is what you can do. Look at greenhouse gases, hump belt, lower bound. Use that corrected F. Or MANOVA, or just compare 2 levels because you don't need both of these don't need the sphericity assumption to be met.
Exactly.
I hope that they can see it.
Okay.
So are we going to need to...
You might be going into more detail than needed. Did you look at this?
No, I didn't get a chance. I don't know. I mean, I have all this stuff written down from last year, so I feel like more is better.
More is better.
So, and then...
Oh yeah, hump belt also has more power.
Right. Best correction. And greenhouse geyser can be an over-correction.
Best correction.
And if it's violated and you don't correct, type 1.
More power. More power to you.
So is it kind of saying that if you decide to use greenhouse geyser, that you're going to have a type 1 error?
No, that would be, it would
Or,
be an
sorry.
overcorrection.
Oh, okay.
So that would be what? Type, the other
Type 2.
one, right?
Yeah. And then the other one's type 1.
So this,
LB.
right, so if you use this correction, it might overcorrect, like it should say.
Not conservative.
Oh, really?
Yeah. And lower bounds was
Too conservative.
Oh, I have that the other way.
Too strict. Yeah.
Okay. Maybe I have it wrong in my notes then, because I have that one as an overcorrection. We should look it up. Yeah.
But
I
we
could've
get the
written it
essential,
Basically, you can tell.
the basics to that. You don't have to mix design. We did go over that next test, right? Mix design.
I mean, that's what he said, but it still makes me nervous. Like,
I have here that it's not going to be on the test.
right, conservative,
Mix
yeah.
design.
So we don't need to know like how to do A, AS, and then A times S, and the degrees of freedom and the brackets for that.
You want to be able to know the error term. So yeah, error terms are on here.
Can we go over that?
Yeah, we can do that. So know where your what your sum of squares is for the within group. Know your degrees of freedom and how you would find that for within groups.
What did you say? I'm sorry.
The within groups, actually the three-way and the within groups, you want to know how to do your degrees of freedom, what the error term is that you need, because there was a lot of error term on that last test, I believe. Okay.
And also back to that greenhouse thing, on page 378, it says that the greenhouse geyser is the conservative F-test. So I think it is the overcorrection. So I don't know, maybe he switched it in class.
Usually you said it backwards.
Yeah, maybe he just said it backwards, but it's definitely, it says here it's the conservative one, and I have in my notes that it's an overcorrection.
So that one's too strict.
That one's too strict, so you probably wouldn't want to use that one. Yeah, you might want to get him to clarify that. I mean, that might be more specifics than you need to know. Like he might.
We need to know.
Right, but he might just want you to know that like those are tests that you use to look at sporicity. But we can ask
We talked
him.
about it quite a bit in class.
Yeah, that's what I think.
Oh, he did.
Yeah.
Okay. Well, maybe he switched it around a little bit because it does on page 378. Oh, sorry, I still have your book.
That's okay.
It says it's the conservative test.
Well, someone email him.
Yeah.
He answers emails quickly.
Yeah, he's pretty good at answering.
Okay, so for bachelor's degrees of freedom.
Oh, okay.
Or we can do the error terms. We can do actually both at the same time.
Which I have the degrees of freedom.
Yeah, I have it here.
Oh, you have it written down. Okay. Oh, yeah, I have that written
So
down.
it's pretty much what you just,
Yeah, here it is.
you should know from your ANOVA tables. Is it okay if I erase this guy?
Mm-hmm.
Do you? Can you get from someone else? Okay.
We can erase that too.
No, I'm going to keep it open.
Oh my goodness. Any other pins?
No.
Where'd they go?
Oh my god. Hi.
Oh wait, here's one.
Oh.
What is this?
Where'd the green one go? That one's the best. Somebody probably stole it, for like another round. I would steal it.
So for the sources of variance, for the mixed, not the mixed, the within subject, you have your A, your S, and your A times S, your interaction. And there is no within, there's no nested, there's no subjects nested within a group, so there's no A within anything with this design. That's the difference. And so your degrees of freedom is A minus 1, S minus 1, and A minus 1 times S minus 1. So remember these degrees of freedom and the sources of variance for this design also. You also have to know expansion of degrees of freedom to bracket term. That's for a 3-way and 4-way, actually, so we'll do this separately.
What do you mean that you just said something about variance? Know the source of variance?
Yeah, so these are the sources of variance.
Oh, okay.
The sum of squares is the source of variance.
Like how to get it.
Yeah,
You're
so
saying?
what they are for the design. Because this is different as opposed to a between groups. Because the between groups
Okay.
has this, if this was a B maybe, not an
Called
S.
source of variance.
Between groups is different because it has, it would have, so if it was a 2-way, it would have A, B, A times B, and then S within AB.
Okay. 2-way.
That's a different source. This is a different error term. Right. It's a different source of variance. Okay?
Got it. Thank you.
And if this was a 3-way, ABC, A times B, B times C, A times C, and S within A, B, C. And that would be, this is your error term now.
Right.
S with nested within A, B, C.
You don't have just regular A times B times D?
Oh yeah, I forgot that one, sorry. The 3-way. A times B times C.
Okay.
So this one has, all these are sources of variance now.
And
The
so
main
that-
effects, the 2-way interactions, the 3-way, and the error term.
And the S is saying like subjects nested within ABC.
Yes. So that's why there's nothing nested within here, because there's no groups. There's no subjects nested within groups. They're going across treatments.
So per se, there's no an error. So there is no error.
This is the error. Well, this is the
So
error
this
term
is
that we're
the error
using.
term.
Yeah, that's the error term that you use.
So we are A by S.
A by S is the error term for within subject.
And then, and it's the one that we use on MS. On the,
Yeah.
Error term.
So once you get to this point, it's the same sort of. MS. This is sum of squares divided by degrees of freedom to get your MS, and then you would divide A. And then F would be actually just the A, it'd be the mean squared A divided by mean squared A times S. So it's this divided by this for your F.
And same with that.
Well, you don't really need the S. You just
Yeah.
need the A.
Isn't ideal.
Because this is looking at the variance that the subjects vary from one another. You don't really, you know that they're different.
Right.
You don't really need
Right, but that's not what you care about
for your
within
for your analysis.
Yeah.
It's not going to tell you anything when you look at that variance.
Right.
Just that your subjects differ from one another, and that's what's expected.
And
They, like, I mean, they might be moving like this, but they're different from one another.
and but
That's okay.
the between group is the same then. Same thing. So we'll use the same.
Between group, you'll use this error term for all these F's. Sorry, it's all squished. So that's what we mean by the error term, sources of variance, and you have to know which error term to select. So if it's a 4-way design, what's the error term going to be?
S times A, B, C, D.
Yes.
D.
A, B, C, D. 4 factors.
4-way. 4 factors.
Am I missing anything?
No?
The expansion of the bracket term.
Yes.
Oh, yeah. That's,
Well, I mean for that concept.
I have that. You want to take that one? So just write out the bracket terms, right?
Did you want that?
Yeah.
Oh.
Well, I'll write it next to this, I think.
Okay, go ahead.
So
three-way and a four-way.
So just write the bracket terms or write the, oh, I see. Like that?
Because remember how we had in class the practice
Yeah, that's
how to
mixed
expand the ABC? And degrees of
Yeah,
freedom,
there's
ABC
like
minus
16.
AB
Oh,
minus
the
AC minus.
foil.
Is that what?
thing. Is that what he means?
That's what it's a mean.
Yeah.
Oh, okay. Okay. So that's just foil. Oh, so I should do it the between group.
First patterns. And then
I'm like, what is he? Bracket. Okay. I'm confused. No, it's gonna be one word. I think it's the other one that works. Yeah. Oh yeah, you're right. I think it's that.
They have the same lid.
I don't know. Okay.
Well, you know your degrees of freedom for ABC.
And this is a three-way.
Right.
What would the
A
AB,
minus one.
AC,
A minus 1, B minus 1.
yeah,
And B minus 1, B minus 1.
and the ABC
It's A minus 1 times B minus 1.
times,
C minus 1.
yeah.
Oh, ABC.
And how about the error term?
So be A, B, C times N minus 1.
So you know all the degrees of
Do you guys
freedom.
know?
Yeah, we
Okay. Right.
Still good to go over now.
Yeah, we can write out, you can write the expansion
Okay.
Get your notes.
since they're long.
Yeah, I think we did this in homework session too, right? Yeah. Do you think we need to go over the mixed design stuff? No. Like, this stuff. Which one? Which
But did he go
error
back to class?
term? No, he didn't. I'm like, which error term?
I can't expect us to.
I think we do.
We didn't go at
You don't have
class
homework on it?
And what he said was that it would be on the next. But I'm so scared.
Well, if he has it on there, then he's going to have to take those questions off.
Yeah, what did I think?
From 11 forward.
Because we didn't get to do the test either. So.
No, I mean, no.
And what he said in class was that the mixed design would be on the next test. That's what he said. So.
Well, then, as long as y'all remember that.
Oh, no, that's right.
Is that is what he said, right, guys?
Okay. So we're going to not go over mixed design, and if he tests you on that, we're going to say no.
Oh my God.
You said you have
No
to
way,
test on
Jose.
that. Okay?
I feel like we need to go steal the green pen again.
Maybe he's getting one.
I'll be getting it first. Okay. What's this one? I don't want to find it.
ABC times n minus 1.
Yeah.
They know it.
See, it doesn't even work.
So once again, this
I don't
test
know.
doesn't have too many concepts on it, but it's going to be
Yeah.
multiple questions on each concept.
There's one other
So how do we
thing.
expand the bracket terms?
So,
Yeah, sorry, the pen died. I think he's getting us another pen. But wait, there was one other thing I wanted to
So when you're,
mention.
an easy way to do this, to change just the degrees of freedom bracket terms, is just 1 equals t. So the bracket term for this is a minus t. It's b minus t, c minus t. And then you would just expand that with the FOIL. So it would be ab minus a minus b plus 1, but 1 turns into t. So it's ab minus a minus b plus t.
So, for that one, it says a times b minus a minus b t.
Yeah, and those are brackets.
And these are up. Yeah.
Thank you, Richard.
Yes, thank you.
Now we can
I
actually.
got it from down the road. I'll start bringing them to the next ones.
We should have our own.
Does that make sense?
And
Everybody
so-
know foil? Okay,
Same
yay.
pattern for these two. So AC minus A minus B plus T, BC minus minus C plus T. And then for the three-way, it's ABC minus AB. No. Sorry. Yeah. ABC minus AB minus AC minus BC plus A plus B plus C minus T. From what you learned in there. So that's expanding these degrees of freedom into bracket terms.
So on this test, is he going to give us numbers, and are we going to have to actually like do a problem or just no
I don't think so. I think he'll probably give you the variables.
So there's no problem to solve.
There might be, if there's any problems, there'll probably be looking for interactions, or is there a main effect here, or is there interaction, is there a three-way, is it two-way,
So like
with
that
a
sheet.
small kind of simple table and maybe a graph. Or maybe you'll have to make the graph to look for the three-way. So that's also something that, did you talk about that yet?
We haven't gone over that yet. And what was that sheet?
Because we're still doing three-way in class.
I had a question about a couple of these things, like from the...
Oh, from what he gave you guys in class?
Yeah, he gave, I'm trying to find that. He gave out a handout.
Well, let's close this up first, actually. And then for the within, for the error term, it's, do you have it? It's y minus abc. ABC times n minus 1 is the degrees of freedom. And y, actually, you can translate that as ABCN. If this was a two-way, it would be ABN, and that would still be y. So y is equal to all of the factors times n, and then t, well, that's just 1. I mean, that's just ABC times 1. So you're just multiplying ABC times n, and then ABC times 1. So this turns into y, and that just stays ABC. So that's expanding that degrees of freedom into bracket terms. I know that didn't make sense to you, because I can see it on your face. But just remember that this one has y. It's y minus ABC. It's the bracket term, which I don't think you really need to know the exact bracket term, but I'm guessing this will be the most important thing because it's the most complicated expansion.
Yeah, I kind of remember this one being on there last year.
Maybe he'll say what,
But I could be wrong.
which he'll probably have options, and it'll probably be like a four-way. I know he went over that in class, so he'd say which of these is the fourth. You might have different options for the four-way expansion. You'll have to know which one's correct. I haven't done tests, that would be my guess. What you do.
Okay.
But I think you guys are good with this, right?
Yeah. Before we go over that interaction, I want to mention one thing that we kind of mentioned but didn't quite cover for the practice and carryover effects that I found in my notes. There's two solutions to dealing with that I have written down. So it's counterbalancing the data and Latin squares. So that might be something that I don't know, that might be something he asked. Like, how do you correct, what's a way of correcting for carryover effects or practice effects?
What was the second one?
The Latin squares. So that's the one we kind of mentioned. So that's just like a systematic way of counterbalancing. And what that means is like switching the order in which stuff gets presented. So like maybe you have half the subjects get treatment 1 first and half the subjects get treatment 2, and then so
And he also said in class that the one thing you can't counterbalance for is time. So like no matter what,
Right.
you can't counterbalance that.
right. So like pre and post, like obviously, how are you going? One has to be pre, one has to be post. So, but that's a way. So just remember like the two words like counterbalancing and Latin squares. Just be able to recognize that. You're probably not going to have to do a lot of detail on that. But you might.
Actually, I'm like helping out with the study right now where I'm administering Rorschach and SPA, this social skills test, and she has it randomly assigned where some people get the SPA first, some people get the Rorschach first, so that whatever the carryover effect might be will be counterbalanced.
Right.
Real life.
Yeah, so that's just, but I just want to make sure you guys, just in case he puts that on there or something. Okay, that's it.
So you had questions on this guy?
Yeah. I mean, I think I understand it a little bit. We can tell if there's a good interaction just by looking at the graph, right?
For a three-way? Yeah. For these graphs, this gives you the C1, C2. So this gives you you'll be able to see a three-way interaction here, but for the two-way, you want to break it down. You want to do, I mean, I think for this example, he just wants to see if he can find three ways in here. And so what is a three-way again? A three-way interaction?
Different.
Different. But what is that in the sentence form? So it's when the simple interactions of the two-way are different across the levels of that third variable. The third variable being C. So if the simple interactions are different across on those two levels, then there's a three-way interaction. So if what you see here in C1 is a different effect, a different interaction than in C2, then there is an interaction, a three-way interaction.
And all the three levels you said?
Well, this one only has two levels, C1, C2. There could be three, but
So like,
he hasn't given you.
okay, so number 4 on that, there's no three-way interaction.
Yes.
Yes.
Can we see them?
Because they're both doing the same.
The same.
Right.
But there is a difference between C1 and C2.
There is,
Or B1. Or the
yeah, there's probably
Like
going to be,
Two-way
B,
interaction.
yeah, B and A.
Right. There's a two-way interaction because, like this graph, it's like at different heights, but it's the same, like the actual graph is the same pattern. So that's why there's no three-way. But because it's like different heights and stuff, like these ones are up here and these ones are down here, then that would be indicative of a two-way.
And A by B, right?
Right. A times B.
but to be absolutely certain, you'd want to have a graph that just has A and B on it.
Right. Yeah.
And he doesn't give you the means here, so you wouldn't, I mean, you kind of have to
You wouldn't be able to tell.
make it up a little bit,
Yeah.
figure it out.
But
with-
you could make up some numbers.
Yeah.
yeah,
of like-
as long as you know how much things are changing across.